All right, so let's talk about what happens when the number of subatomic particles within an atom changes. As we probably remember from our earlier education in chemistry, an element is defined as having a fixed number of protons. So that means we categorize our elements by the number of protons they have. For example, helium has 2 protons. Every helium atom has 2 protons. Not 1, not 3, not 87, but 2. Only 2. If we change that number, we have a different element. For example, if we add a proton somehow, we would get lithium, which has 3 protons. Or if we had subtracted one, we would get hydrogen, which has just 1 proton. And so we're going to see that on the periodic table, these elements have numbers associated with them. For example, here's beryllium. On the periodic table, we would see it as so. We'd see Be, which is the abbreviation for beryllium. And we're going to see the number 4 at the top. And that number tells us the number of protons in a beryllium atom. So every single beryllium atom has 4 protons. We'll see that the numbers of neutrons and electrons can change, and things will still be the same element. But the protons must always be fixed. So that's not something we can really change or something that we observe. If it has a different number of protons, it's a different element, that's that. No further exceptions. So let's talk about electrons then. Electrons, which are the other charged subatomic particle, can move relatively easily. And in fact, we're going to see the majority of chemistry as we know it happens with electrons, as electrons move from one atom to another. And so we're going to see that when atoms gain electrons, and remember that electrons are negatively charged, and if electrons are negatively charged, getting more of them means that you're adding more negative charges to your atom. They become what are called anions, or negatively charged atoms. We're going to call ions any charged atom. So an atom that has an unequal number of protons and neutrons will be an ion. Specifically, ones that have gained electrons are negatively charged, therefore, we call those anions. On the opposite side, when atoms lose electrons, they become cations, or plus charged, positively charged. So considering that if you gain something negative, you become more negative. If you lose something negative, you become more positive. Remember that the protons and electrons have the same but opposite charge as each other. 1.602 times 10 to the negative 19th coulombs. Every one of those that we add electron-wise adds 1 negative charge. Every electron we take away removes the negative charge, or we could say adds a positive charge. It's just your frame of reference there. So just to reiterate as well, any charged atom is called an ion. Positive ions are called cations, negative ions are called anions. So, and this happens when electrons change. So ions form as the number of electrons changes. Electrons are represented by E-, by the way. I know I've been writing that. E- stands for electrons. All right, so they form as the number of electrons changes. And we can also calculate the charge of an atom the charge of an atom is simply the number of protons minus the number of electrons. And so normally in a neutral atom, the number of protons and neutrons is the same. For example, lithium has got 3 protons, 3 electrons. The charge, therefore, is 3 minus 3 and 0. However, if lithium loses an electron, if we say it's lost an electron, meaning it now has 2 electrons, the charge is 3 minus 2, which is plus 1. And so we'll indicate that by putting a plus next to the element's symbol. And so we'll write a single plus. We don't need to write the 1. That's not something we do in chemistry. We like to abbreviate. And if we had something that had 2, for example, if this particular ion had 1 electron only, which is unlikely, but if it did, it would be a 2+ ion. It's again not likely to happen, and that's something we'll find out why later on in the semester. But suffice it to say right now, lithium 2+ doesn't normally exist, but we could theoretically make it. And we would write it like so. We would write Li, the abbreviation for lithium, and we would write 2+, indicating that its charge is plus 2. Again, this is something weird about the chemists, but we put the number before the sign. So in physics, of course, you would never do that, but in chemistry, we do. Less commonly, sometimes in biology, although it is not acceptable in chemistry to do this, you might see it written like so. You might see it written Li++ for a lithium 2 ion. Again, it doesn't exist, but if it were to, that's how you would do it. So, or you might see it in biology, like calcium, which normally forms a 2+ ion. Biologists sometimes write Ca++, and that's a no-no for chemistry. So just be aware of that. So the conventions are important here. Conversely, of course, if your ion had more electrons, for example, if now it's got 4 electrons and 3 protons, you do 3 minus 4. 3 minus 4 is -1, and we would put a minus there. Again, we don't include the 1, but if there was a 2, if it were -2, we would say 2 minus for the lithium. All right, so hopefully review still. This kind of first couple chapters are usually just review, but we're going to make sure everyone's on the same understanding before we actually talk about chemistry. So in our next video, we'll go over what happens when neutrons changes, which is something called isotopes, as we'll see, and we'll see how atomic mass is calculated as well.